Thousands of teams use Atlassian tools to get work done. But what if you can make those tools even more powerful? Like automate workflows, gain valuable business insights, simplify admin tasks, format and share important content, and empower your dev team to work smarter. AppFire's growing portfolio of helpful, trusted apps provides solutions to all of these challenges. So if you want to improve your team's collaboration and productivity, AppFire's got you covered.
Hello everyone, today we're going to talk about how to scale Atlassian tools at your fingertips with Kubernetes. Today we're going to talk about how a manual deployment works and how an automated deployment works. Then we're going to talk a little bit about how to do performance and scaling on an automated deployment. And then we're going to conclude by differentiating between manual and an automated deployment. In a typical deployment, you would use a manual deployment. In manual deployment, the primary thing that would you choose is what kind of environment that you need actually. So it's like, are you going to use a cloud or an on-premise environment? And you definitely use some kind of SQL, Postgres, or Oracle, and you need some kind of a shared file system and a load balancer. And in a manual deployment, how does it actually work? You might have asked yourself. So in a manual data center deployment, you have multiple applications nodes deploying on a similar with a similar configurations, and which uses the same set of shared file system and a database. And that's how a typical Atlassian manual deployment works. But have you ever asked yourself, imagine yourself, what kind of challenges are you going to face with your manual deployment? Is it like properly scalable? Is it like, are we optimizing the resources of our deployment of Atlassian toolset? Are we utilizing utilizing the infrastructure to the fullest? Can we do zero downtime of everything? I'm pretty much sure you've asked about these questions a lot of times. Now, can we ask ourselves, like, can this all be automated? Can the entire deployment that we are doing, all those manual clicks and all those commands that we type in, can we automate all of those? And can our automated deployments automatically self-heal on failures? So we have asked the similar kinds of questions ourselves. And we thought, like, in a manual deployment, everything that we are doing are repetitive tasks. And every time we try to do this repetitive task, we asked ourselves, like, hey, can we automate all of this? Finally, we decided that our solution is going to be, we are going to use automated deployment for our enterprise application deployment of Atlassian tools. And we're going to automate it through our CI/CD pipelines. All the manual tasks that we do day to day for deployment, we're going to use those as configuration as code and deploy them using our CI/CD applications. And the trick is to that we are going to use these application nodes as a containerized deployments using Docker images. And we're going to manage these containerized applications using Kubernetes. And let me talk a little bit about our team at ADP. We are an Atlassian team of 5 people. Myself, Dikshit, I'm a principal application developer, and we support 20,000 plus users. Shiva and Kishore are our Atlassian administrators who work with our users and solve their day-to-day use cases and do POCs and troubleshoot their requests. And we have Satish from our performance team who helps us understand our scaling requirements and challenges and help us prepare better to serve our users. And we have Peshing, who is our DevOps support engineer who helps us automate all our stuff and also who's our expert in Kubernetes. But now that we know we have to deploy a Kubernetes automated environment, it doesn't mean that it's very ready. We have some challenges that and every organization will face whenever they're thinking of going through the Kubernetes or automated deployment journey. The primary thing that they need to decide is like what kind of environment they're going to use. And then they're going to decide like what kind of Docker images they have to use. Then they're going to talk a little bit about storage. And storage is an important thing. And finally, health checks. Health checks make your automated environment much more stable and go through all the scenarios that help you out in solving all your challenges. Now, let's talk a little bit about environment. Environment is an important thing, and when you choose environment, you have a long list of options to choose from. but what to choose and what is right for you is like there is nothing that fits right for everything. Whatever is available in your organization, go with that. Here is our recommendation, and here are some of them that we have used. But if this is not available in your organization, if you have something else, go with that. You can choose either infrastructure which is cloud or on premise, and you can use Kubernetes, which can be managed like AWS managed, or an open source Kubernetes, and definitely have some kind of monitoring enabled with it. And you might want to externalize your logs and send it out to Splunk or Elastic. And database is an important thing. So as you know, there is a bottleneck problem with this database. It's like you can only have one database, but if you use some kind of databases like Aurora DB, you will be able to have multiple readers and a single writer. So that's why you might consider using some of the databases like Aurora DB. And of course, you want code management and repositories to store your code. You can use Bitbucket or GitHub, and any of the CI/CD applications works. It doesn't need to be like Bamboo or whatever you use. It can be like whatever it fits in, whatever is available in your organization. There is a wide range of selection of Docker images that are available on Docker Hub. You can choose any one of them, whatever that fits in your organization, whatever you want, and whatever is suitable for you. You can go with that. But whatever you choose, don't try it out on production directly. Make sure to test it out in a production like environment before deploying it onto the production. And these are the two Docker images that we use. And you also have Atlassian's officially supported Docker images, which Atlassian releases too. You can choose those two. And coming to storage, storage is an important concept in Kubernetes. There are two kinds of storage you might stumble upon. One is a persistent volume and another is a non-persistent volume. And using a persistent volume is something like EFS or NFS that doesn't get deleted, and that all the nodes keep accessing those files, and which doesn't need to get destroyed on restarts or something like that. That is called as persistent volume. Whereas non-persistent volume is something which gets destroyed, and these are similar set of configurations. Even on startups or redeployments, you would you would just need to use the same set of configuration and files, and much of the changes doesn't happen on this. So this can be your application notes or installation files with Jira users, and these doesn't need to change on each and every deployment. But be very careful when you're choosing this. Let's say you have home paths set up on these non-persistent volumes, and if you require those logs, it's better to externalize those or use part of those log files as persistent volume as those directories, and rest of them you can just use non-persistent volumes. And this is an important factor on the storage. Always use SSD if it's available, and always use fastest whatever is available, because SSD affects a lot. You need something which has high IOPS and which is very fast, or else your application will see a lot of issues. We have faced a lot of challenges with IOPS too. In our instance, we have seen that we deployed some kind of EBS, one of the EBS with low IOPS, and it impacted our system pretty badly. It caused slowness on the node, and that slowness on the node, that IOPS issue eventually diverted to CPU high utilization, and even affected the entire cluster, which impacted the database connections too, and eventually everything became very slow. And that's the reason why you need to use something which is fastest. And in another scenario, we use like rotating hard drives on a on-prem instance, and it was causing issues with add-ons update, add-ons installation. The changes would not replicate, and that would cause a lot of issues too. That's the reason always use whatever fastest that is available, and prefer SSD if possible. Next, we're going to talk about health checks. Health checks are very important. And in Kubernetes world, you have liveliness and readiness health checks. So these govern around and manage your Kubernetes environment and the Docker pods on how and when to restart them or when to remove them out of traffic. So you would use like liveliness and readiness probes to configure this. And you would need something called as pod affinity too. Like Kubernetes optimizes your resources, and it helps you deploy these containers inside probably one machine. If you have enough resources, you can deploy these two pods into one machine, and they can both live on the same machine and save a lot of money on the infrastructure costs. But make sure when you're deploying production like instances to try to make sure you have enough resources, or else your memory intensive tasks might make it fight for the memory and resources, and might shut down both of them. Like if you're trying to do like bulk edits or indexing during those time, you might need more resources. So that's why you need to set up a pod affinity and configure number of replicas on the liveliness health checks. It's like you might want to use more replicas or like more application nodes when you have more traffic, and less application nodes over the weekends. So that helps you out to configure these health checks. And here is an example of our liveliness health check on the readiness probe. We use general curl command. This helps us to see like if Jira is alive or not, like is it in a status of running or not. If it doesn't, then it would automatically restart, or it would based on the scenario, it would also put it out of the cluster, and that particular node which is not uh, having a status as running, until it has status as running, it will not put it back to the cluster. So this will help you out. And now we're going to talk a little bit about how a manual and a Kubernetes deployment architecture actually looks like. You might have seen this diagram a lot of times in the Atlassian community and conference pages, and you might have even stumbled upon it, and you started thinking about like how does the data center architecture actually looks up. It's pretty straightforward. It's like you have multiple application nodes which has shared database and shared file system, and you'll have a load balancer to route your traffic to the network. And now let's compare it with automated deployment on Kubernetes side. It's very much similar. Like I told you, we are using Amazon Aurora because Amazon Aurora has multi-AZ deployment, and you can have multiple readers. And in case one of the writer goes down, the reader can be converted to a writer. And we are using EFS. So we are using AWS architecture on the Kubernetes side, completely on the AWS infrastructure. Now you're seeing that individual Docker pods are deployed onto the EC2 instances, and you're using AWS managed Kubernetes to manage the Docker pods, and it can do the self-healing, automated rollbacks, and of course, Nginx. We're using ingress controller over here. The reason behind that is certain tags might not be existing to automate the deployment using code on the AWS basic load balancer. So ingress controller is going to act as your load balancer to communicate the traffic from calls from load balancer to the pods, and the pods to the load balancer. Now that we have seen how we deploy Atlassian toolsuite onto the Kubernetes, and we also looked at the architecture, let's talk a little bit about scaling challenges that you're going to face with Atlassian toolsuite. Okay, what is the primary reason we always scale our Atlassian toolsuite is? Of course, user growth. The more users are going to use the application, the more challenging it becomes, and more performance. You'll see all kind of performance issues. You'll need to increase your RAM, CPU, and again, you don't know what to increase it, right? Users are growing, and you're seeing some kind of the other kind of issue. So how do you know what kind of problems your instance is going to run into? That's what performance testing helps you out with. And once you do this, you're going to also run into one more big challenge, that is indexing challenges. And you're going to see like what are the indexing challenges you're going to face when you're scaling out the infrastructure, and how do you manage them. And finally, once you have all this, you're going to decide on how to scale your instance. That is like if you're going to go as a horizontal scaling, or you're going to vertically scale. That is like adding more replicas to your application nodes, or are you going to just improve your CPU, or are you going to add more RAM? So let's talk about growth of users at ADP. We started in 2018 with about 500 users, and we started growing pretty fastly. And today we are about like 20,000 users, and we are still growing. And by the end of next year, we are planning to go to 50,000 plus users. Yep, we have a lot of challenging user group, and we had to scale up our instance very often too. And our performance test really helped us out with our user growth to to manage our instance. So let's talk about how a performance testing and scaling actually works. Actually, how do you determine what kind of performance testing to do? So you don't need to do everything from scratch. You can use what Atlassian used. Actually, Atlassian did release JPT, Jira Performance Test framework. You can use that as a starting point, and you can simulate your own data by adding uh, dummy data using Jira Data Generator, and use some applications like Load Runner. That's what we used. Up to you, whatever is available in your organization. And you can simulate all the performance testing framework recommendations like calls, and of course, add your own calls on top of it. And of course, you don't need to figure out everything from scratch. You can take a look at what Atlassian scaling and Jira sizing guide talks about. And we went with that and we added our own use cases to that. Then we finally figured out what works for us too. And in the performance testing, one of the important thing that you have to look at is like, what is your methodology? Identify who are your active and who are your passive users. So what is an active and a passive user? Actually, active user can be someone who is logging into the system, or he's someone who is performing some kind of activity like editing an issue, creating an issue, searching for an issue, exporting some kind of JQL report. And whereas passive users is someone who has logged into the system and just idly looking at something, or he browsed something and he's just looking at that report or looking at a dashboard. But those still count as kind of active users. But you need to have a combination of like who are active and who are passive, and understand their operations that are performed based on their utilization. And finally, here is our insights on our performance tests that we did. And we used all the Atlassian's JPT recommendations and added our own requirements. Like we have Jira Align, and we use Jira Align calls to this activities on the transactions, and we perform these calls. And we did multiple tests, and this is one of the most good looking one. So it's like what we found out was, in our initial use case of about 8,000 users, and with about 20,000 users with about 1.5 million issues, we have found out that our current infrastructure that we were using, the database was hitting 100% CPU. So, and all our transactions started failing. So we had to jump onto a better database. And after upgrading the database and using C59X large instance, it was pretty good. We were running smooth, and we were able to. We did our endurance test too, and we passed out like 529K transactions without any issues. And finally, we had to understand where our future is. We know that in the next year, we might have around 3 million issues. And we added some additional operations related to Jira Align and our own use cases. And when we performed these tests, we didn't need to change anything on the infrastructure, but we had to change a little bit on the memory side. So if you observe in the previous slide, we were at 20 gigs of memory, but in the future, we might go to around 48 gigs of memory. And in our endurance test too, we found out that we ran it for about 8 hours, and nothing went wrong. And again, this is for about 3 million issues with about Jira database size of about 71 gigs, and our index size went from 3 gigs to 11 gigs, and with an active user count of about 8,000 users hitting each node. Now, let's talk about indexing challenges that you're going to face on scaling your infrastructure. So the primary thing that we have seen on the Kubernetes side is like whenever something happens during the automated deployment, it would have like broken indexes on restarts, or like when we stopped when we were doing rolling restarts or perform some kind of maintenances. And we also had this urge to do reindexing on demand, actually, because let's say some of the indexes are out of date, and the reports are not coming up properly. And because there's a lot that happens on the data center side, and it's like you'll do a lot of operations, more the users, more operations. You'll be adding on the administrative side some custom fields or update some workflows, and you'll start seeing the indexes are out. And so at the time, you might want to do lock and reindex on demand without impacting users. So we solved this too, by using one of the community posts and with the help of Premier Support, and of course Valiant is our preferred vendor. So we used one of this community posts as an example, and we designed our own code, and we use that code to start our instances. So what it does is, like, whenever the node starts up, the primary thing it checks for is like it checks for index snapshot, and if it doesn't find it, it will automatically use the most latest index snapshot, and so and start up the instance. And with that, you will not see you will see that every time a node starts up, it will always start up with some indexes. So that helped out. And then we wanted to solve the zero downtime reindexing too. So we wanted to reindex on demand. So what we did was, like, we added a health check. We referred Atlassian documentation. Atlassian does talk about it. I'm including all the documentation links over here. You can refer it and utilize it. And it doesn't matter. These indexing challenges can be used even on a manual deployment. So what we did was, like, we added a health check on one of the load balancers, and of course this can be on the pod health checks too on the Kubernetes side. That if you are doing a manual deployment, you can do it on the load balancer side. So this health check checks, like, whenever you do start at lock and reindex, it would send the node health to maintenance instead of running, and during that time it would automatically move the cluster out of the traffic, and until the node status becomes again running, it will not put it back into the cluster. That's all does zero downtime reindexing too. Now, now that we know all the performance changes on how and what to scale to, let's say you're using C5 4x and your future infrastructure is C5 9x, and how do you apply these changes actually? It's very simple. The code changes, these are all code changes because you configured everything as code. It's as simple as editing one line of a code from C5 4x to C5 9x. Here is a sample code that you have. Let's say you're using C5 4x, you would go over here and edit it to C5 9x. And let's say you'll have to horizontally scale, you would change your minimum instance from 3 to 4. So using this, once you change the code, and if you have direct permissions to commit the code, if you commit the code, it would automatically deploy the code and start up and shut down your old nodes and deploy the new nodes in a rolling restart fashion without any downtime. Or else, if you have someone to review, make sure to generate a pull request and someone can review your code. That always helps and does the same thing in a rolling restart fashion. It's going to deploy, and it's going to not cause any downtime. And this is our ADP's configuration. So we are at C5 9x. We are about 1.5 million issues, about 18K users, and we are still going up, climbing up. And as you can see, in our performance test, we have seen that custom fields affect a lot on performance. And these kind of tests and exposing these kind of tests to our users also help to lower custom fields on our instance too. Now let's talk a little bit about Kubernetes myths, and let's break those Kubernetes myths. So the first one is hard to manage. I've heard people say that, like, oh, isn't it hard to manage Kubernetes infrastructure on Atlassian tools? It's like, no, as long as you have the underlying concepts of the infrastructure doesn't change, even if you're using Kubernetes or manual deployment, it's fairly same, and it's easier to manage if you have the right team who is training, who has enough experience with Kubernetes and this kind of deployments. And of course, a fine Atlassian administrators would definitely help it out. And there is no Atlassian support for Kubernetes deployments or automated deployments. It is supported with some exceptions. Like I told you, like the underlying concept of Atlassian's support does not change. Doesn't matter what kind of infrastructure you're using. If you're using AWS or if you're using on-premise, as long as you can give them a support zip and on using and the previous support will look at the support zip and tell you like where the problem is. But at the end of the day, you need to resolve it. So, and also Atlassian officially releases the Docker images, so which you can use to deploy it on your environment. And the final one is like, it's a time-consuming infrastructure deployment. It's like, no, it's not a time-consuming. At first, probably trying to figure out everything might take a little bit of time, but as you move along, you'll save a lot more time on the infrastructure because these are all repeated tasks that you're automating, and your administrators can focus on more important jobs than this. And it's fairly easy to migrate from an old Kubernetes, old manual deployment environment, or like whatever, doesn't matter the size. You can always copy over the data from uh, the manual deployment to the automated deployment without any problem. We do it once every 2 months. We take over production data and dump it to a production-like environment for our testing without any problem, and it's all zero downtime. We did our migration to Kubernetes 2 on zero downtime. And finally, I would like to conclude by comparing the differences between a manual and an automated deployment. In a manual deployment, you would always need a person in between who knows how to operate and know all the commands and clicks where he need to do in doing a deployment, or fixing an issue, or do a maintenance. Whereas in an automated deployment, all the things that you do regularly, you organize them and put them in the form of code, and you deploy them. And so everything that you do over here is automated, and everything that most of the time that gets deployed is always zero downtime, and you can automate most of this stuff. And let's say if something goes wrong on the manual deployment side, let's say in the middle of the night, you'll have to go in and manually look for the problem. Let's say if Jira service is down, you'll have to go in and you'll have to type down some of the commands to start or stop the service. Whereas on a Kubernetes deployment, trust me, it will save your sleep. It did mine for sure. So in our experience, we did get a lot of issues. And at midnight, even at midnight, we got a message saying that, oh, there is a service that went down, a notification. And quickly after 1 or 2 minutes, we got the message saying that it's resolved, and we didn't have to go in and do anything. So with automated deployment, you'll save a lot of time, optimize your resources, and even you don't need to have a human intervention in middle. So we would like to tell everyone that treat your Atlassian tools like a piece of software that you develop. And the piece of software that you develop, you would automate its deployment and have self-healing capabilities associated with it, so that it doesn't go down that easily. And I'd like to thank everyone for giving me such an opportunity to present this presentation at Team 2021. Thank you, Atlassian, for giving me such an opportunity. And I'd like to thank Premium Support, our TAMS, and our partner, Valiantis, our Atlassian partner. Thank you.